So thank you very much for your visit to Montreal, I guess. There's enough, I guess. Okay, so the idea is to give you a kind of overview of the evolution of science policy in Quebec and Canada, because the contrast is interesting. So we will go in a historical approach. When we talk about science policy, we tend to talk about explicit science policy. If we talk about science policy, it means that there is a state, there's a government to think about science. But before having an explicit science policy, which as I show will emerge as a concept in the mid-1960s, there was, of course, what some call implicit science policy, because in fact, government needed science to develop society, to develop economy. So let's begin before what I call the era of the National Research Council. The first fundamental date is 1842 because it's the creation of the Geological Survey of Canada, which helped to develop a viable mineral industry. We are in the development of the Industrial Revolution. Everywhere in the world, in England in the 1820s, in New York, the New York Geological Survey, there are geological survey everywhere. Why? Because they're searching for coal, which is the fuel of the Industrial Revolution. So Canada is no exception. So they create in 1842 the Geological Survey of Canada, directed by Sir William Logan, who've come from Nova Scotia, and a first geological inventory of the Ottawa River. And it's important to call that with the United Canada in 1841, following the rebellion in Montreal of the 1837, 1838, and in Higher Canada, there was also a rebellion led by Lion Mackenzie King. The British government decided to fuse Ontario and Quebec into one government called United Canada, and we tend to forget that the capital of this United Canada was in fact in the old Montreal. And so now it's in Ottawa because in 1849 a riot burnt the parliament in Montreal, and you can see the remnants of the old parliament in Montreal, and you will learn why it has been burnt in 1849. Another step for the case of Quebec is the creation of the first French-Canadian journal devoted to science called the Naturaliste Canadien, created in 1868 by l'Abbé Léon Provencher, and it's the oldest French publication in North America. Of course, it's on botany. It's the mid-19th century. Everyone is interested in nature, so we look for ants, for plants, for things like that. Third date, which is for the Canadian case, is the creation in 1882 of the Royal Society of Canada. It's very interesting because the Royal Society was created, in fact, by the Governor General, the Marquis de Lorne, because he said, okay, I'm the Governor General of Canada. Any real country need a Royal Society. It has to show that it's a modern state. So like the British had since 1660, the Royal Society of London, the Marquis said, we have to create the Royal Society of Canada. The problem is that he looked around and said, well, where are the scientists? So he called William Dawson, who was the head of McGill University since 1855, and asked him to find in the country all the good enough scientists to be named at the Royal Society of Canada. So Dawson answered back that, well, we are about 5 or 6 across the country, so it's not exactly a good idea to create a Royal Society, but I do my best. So he called in Quebec, he has l'Abbé Laflamme, he has l'Abbé Hamel, he look at U of T, where there is someone in the anthropology department. So he finally find about 1,000 scientists to create the Royal Society of Canada. So it's really the beginning of scientific development, and we'll see that in fact it will be essentially during the 20th century that we can really think about the development of science in Canada. But the state, which created in 1842 the George Carl Survey for the economic development, created also the central experimental farm that we see in Ottawa here in 1886. Why? Again, for economic reason, about performing research on the improvement of agricultural method and crops, because we have to control pests and things like that, again for economic development. So the state intervened in matters of science without having an explicit science policy. The real turning point, I think, is the creation of the National Research Council of Canada in 1916. This was created, of course, in the context of World War I. 1915 in England, they created the Department of Scientific and Industrial Research, which is the equivalent of the NRC. The United States in 1916 created the National Research Council. The Japanese did the same, which means that during the First World War, all the states around the world realized that they had to create an organization to think about the coordination of scientific and industrial research. Because though we tend to think about the Second World War as, where science was important, science was very central to First World War also, for different reasons, more on physics, chemistry, things about mustard gas, things about the demagnetization of the boats because of magnetic mines, about techniques to localize the enemy batteries. So there was a lot of physicists, chemists, mathematicians also, which played a role during the World War I, at a scale much slower than the second one, but nonetheless very important. So the National Research Council is created in 1916 to coordinate scientific and industrial research. That's their definition. The problem is that they make a survey about, okay, we have to coordinate research. Let's make a survey of what's going on in research in Canada. And they realize that the total amount of the budget across Canada is in fact smaller than just the R&D budget of MIT, which means that there's essentially no science in Canada in 1916. So it's okay, instead of coordinate scientific and industrial research, let's stimulate scientific research. So they first create 1916 bursaries and grants to PhD and master degree students and grants in aid for researchers. So it's the first funding systems that started in 1916. And then, of course, those research will be going on essentially in universities. That's what is the state of university. McGill was created in 1821, but essentially universities developed not before the 1850s. It's with the arrival of Dawson at the head of McGill that in 1855 that then we can really talk about the development of university. Before that, it's a college with not much students and not much importance. 1852, we have the creation of the Université Laval. 1873, École Polytechnique de Montréal. At the same time as the Engineering School of McGill, because of course it's the era of railways. We need engineers, so no surprise. 1871, we create Engineering School at McGill, and for the Francophone, the government created the École Polytechnique de Montréal. Finally, the University of Montreal is created in 1920, because before 1920, it was essentially a local development of Laval University in Quebec. There was only one university, Laval, who had a succursale in 1886 in Montreal. So Polytechnique is independent of the University of Montreal. So it's the equivalent of its Faculty of Engineering, but it's not a Faculty of Engineering of the university as with McGill or Concordia. It's an independent government-created organization. Another very important organization that will come out in Quebec after 1916 is, of course, in the tradition of the famous British Association for the Advancement of Science, which was in 1831, followed in 48 by the American Association, 72 by the French Association, and in 1922, very interesting, by the French Canadian Association for the Advancement of Science, which held then its first meeting, annual meeting, like the BAS, AAAS, every year there's a meeting in different cities. So since 1933, ACFAS is meeting every year, and it meant 2 weeks ago, for example, in Chicoutimi, where there is about usually 5,000 people going there, and more now with international people like the French come, the Swiss. But it's essentially a Quebec organization. And you can think about why, in fact, since all the country I can tell you about in 1948, the Pakistan Association for the Association of Indian, every country has an association for the advancement of science, except Canada. So let's think about it as a homework. Why Canada has no Canadian Association for the Advancement of Science? So I wrote a paper on this so you can check it. Why? I won't tell you. It's the homework. Which is bizarre, because it's American, French, everywhere. No Canadian Association for the Advancement of Science. And then, yes, as I said, 1923 for Quebec is very important because you see that just after the First World War, there is a tremendous development of science in Quebec. University of Montreal is created in 1920. 1923, the ACFAS is created in the urge of developing French-Canadian scientific careers and to promote also a positive image of science. And the central guy in all this development is Brother Marie Victorin, who created, of course, the Jardin Botanique de Montréal, who published the famous the Flora of Quebec in 1935. So he's a central figure of the development. And also ACFAS, it's very important because it played the role of spokesperson for science. Like the AAAS in the States is talking about science as an organization. Which in terms of policy is very important because political people want spokesperson who is talking in the interest of women, of child, of any organization. And ACFAS has been created in 1923, so has been asking the government, let's put an investment in science, let's create a school of management, a school of anything, let's promote science. And this is important because, in fact, the absence of the Canadian Association for Advancement of Science has made the absence of a national Canadian voice to speak on behalf of science, as opposed to ACFAS, who will see that. Back to Canada. NRC is created in 1916. It helps train master degree PhD students, give grants to researchers. Of course, the consequence is that research is expanding. Research is expanding means publications are expanding, and Canadians are sending their papers to US journals and British journals. So then H.M. Torrey was the president of NRC, said, Canada shall never get recognition scientifically until we have some science journal of our own. That's the foundations, so a nationalist foundations, to the creation of the Canadian Journal of Research in 1929. Then, of course, it will expand in ABC, and it will become, in the 40s, Canadian Journal of Physics, Canadian Journal of Chemistry. Now you have Canadian Journal of everything. So Canada exists through its scientific community, through the Royal Society, so it's a national building through science. And it's explicit, he says it, so you don't need a big theory. The guy is enough conscious that he's creating the thing. Another thing which was not there, in the US you have the National Bureau of Standards at the beginning of the 20th century, you have that in Germany, you have that in England. So NRC says, okay, we give grants, we have the journals. So we see that it's the NRC people who are in fact creating the infrastructure of Canadian science at all levels. So it's okay, we need a Canadian Bureau of Standards. It will be the National Research Laboratories built in 1929. Here it's a book we did in Scientia Canadensis for the 50th anniversary of, or 17th, I forgot, some anniversary of the NRC, and there's a lot of good papers in this special issue of Scientia Canadensis. It's free online. You can see that. And why then, you will ask, are national labs only in 1929 and not 1916 or 1919? In fact, the NRC people tried to create NRC labs in 1919, but they were blocked by university presidents. Toronto, Queen says, no, don't create national laboratory in Ottawa because you will bring our researcher and university to get out of university and go back to your labs. Because of course, a good university researcher does not like to teach, so he will go in the labs in Ottawa. So they said, we will lose our best researchers. And of course, they said, no, that's not the case. So it took 10 years to convince university that you can have national labs who are not there to do pure research. They are there to do standards, usually. That's their job. So they said, okay, we accept this. And now we have, as you know, we have national research council labs across the country in all the provinces. There are biotech here, aeronautics in Montreal too, so everywhere. Biotech. And so you had National Research Council was in fact doing the equivalent of giving grants. So it was in fact a funding agencies at the same time as the Research Council. And in Quebec in 1936, on the urge of ACFAS, the Quebec government created a provincial office of scientific research, which is a kind of small equivalent of NRC. They give grants also to researchers, and here we have the meeting of ACFAS in 1936, so we see we have already maybe 100 people going to the banquet, as usual. And then we go after the war. Of course, there is a classic report that everyone knows across the world because the United States is now dominating the world. 1945, you have this famous report called Science, the Endless Frontier by Vannevar Bush, which says, okay, science has contributed to the war. Now, the government must in fact subsidize science. And it is in this report that is the basis of what will become in 1950 the National Science Foundation. So in 1950, the National Science Foundation, which is seen as the kind of basic organization for subsidizing pure research. But we tend to think it begins there. It's a purely Americano-centrist way of things. In reality, as we saw, it's in 1916 that the Canadians created a granting agencies. It was called National Research Council, but in fact, it was in fact giving grants to pure research. And the reason was, we can read it in the annual report of the NRC 1919, that the training of a body of young men capable of course at the time there was no woman, okay, or if they were there, they were invisible, so they say men. The training of a body of young men capable of prosecuting research in pure science and ipso facto in so-called industrial research. So we have there the ideology of the linear model, okay? You train young men, pure science, and at some point, trickle-down effect, you will have some so-called industrial research. So why do they say that? They say that because NRC was there to coordinate scientific and industrial research. They said, there's no such thing in Canada, so let's do pure research first. Why do they say that? Because of course at NRC, when it has been created, there were only pure scientists. They look around, okay, they took a university professor, John McLennan in physics in Toronto, Rotten in chemistry at McGill. Those are scientists. They say, okay, we'll use NRC to develop pure science. And don't worry, trickle-down effect, you will get at some point, ipso facto, industrial research. So the linear model is the official ideology of scientists. It's not the creation of sociologists of science in the 50s or 60s. It's the professional ideology of pure scientists. Now we come to the era, I call the era of science policy. This began in 1968 with the Science Council of Canada, which is created to advise government on public matters of national importance in science and technology. Remember, it was closed down by the Conservative government in 1993, Brian Mulroney, and you will have, as you know, 20 years later, 10 years later, again another Conservative government that will destroy most of scientific organization. And also in 68, you have the big development of universities in Quebec with the creation of the networks of University of Quebec, which is based on the state university, the California university system. So you have University of California, Berkeley at San Diego, at somewhere else. So they said that's a good idea to have a network of universities. So they created the network of University of Quebec. So here we have UQAM, Chicoutimi, Trois-Rivières, Rimouski, everything, etc. Now come this official science policy approach. OECD start not annual, but country reports on science policy, and he published in 69 the report on science policy in Canada. So it's science policy. In Quebec, 69, they create the Centre industriel. That's very interesting because the CRIC is in fact a para-governmental organization to help SMEs who have competition problems, some R&D problems, but don't have the money to hire all big engineers. So they go to CRIC, which try to solve all the problem of those small SMEs. And in fact, that's this kind of model that the reform of the NRC was trying to do over the last 10 years, transforming NRC Lab into a kind of Fraunhofer Institute. Of course, the German model is always better, so let's Fraunhofer Institute to transform NRC, in fact, as answering problems of SMEs, which is what the CRIC is doing since 69. So, science policies everywhere. In Quebec, 1971, Inter-Ministry Committee on Science Policy for Quebec. The principles of science policy for Quebec, 1971. 1971 also, in Canada, Senate report on science policy. So you see, everyone is talking about science policy all across the world. It's the discourse of the OECD who says you need national science policies. Science is important. So, consequence, in Ottawa, Ministry of State for Science and Technology is created in 1971. Ministry of State, remember in the structure of government, it's not a ministry, it's a ministry without money. So it becomes Ministry of State. So it's a public figure, but it does not really have forces. It's very important. If they had the Ministry of Science and Technology, then it's serious. Ministry of State is better than nothing, but it's not the real thing. It's a simile. 72, the Quebec create 3 councils. In fact, that will become 3 councils. It's the equivalent of the Ottawa one. In Ottawa now, you have SSHRC, which is the Social Science and Research Council. That's the equivalent of FQRSC. You have the NSERC, National Science and Engineering Research Council, the equivalent of FQRNT. And you have the Canadian Institute of Health Research, CIHR, the equivalent of FRSQ. So you see, in Quebec, they created the same structure as in Canada. They just copied the same thing. NRC was the Groupe de Recherche du Québec en 36, in 1936. Now, in the 72, they created the Fonds d'aide à la recherche, which was a big one, having all the 3. And in 2000, they separated the one big thing into 3 separate things. They modernized NRC in 1977, sorry. So they transformed that in 3 councils. Why? Because, of course, science was developing, NRC had its lab, but NRC was doing everything. So the government said, okay, there's a kind of potential conflict of interest because NRC has its labs, has its researchers, and it gives grants to university. So it's a bit of a mixed bag. Let's separate those. So now NRC is a lab, and the research councils are independent councils since 1977 with their own board. 3 different ones. Quebec Science Policy, 1979, towards science policy for Quebec. So you see the word is always science policy. Again, Ministry of State, better than nothing, for science, it's a guy on the left. Camille Lorrain was the first Ministry of State for Science and Technology under the Parti québécoise. Now, 1980, Though here they create the Ministry of State for Scientific Development, it's in fact the end of science policy era and the beginning of technology policies. So you have 1982, le virage, the technological turn. You say, okay, we're doing science. Whoops, yeah, let's turn that to our technology. Why? Because, of course, economic crisis. You have to look about jobs. Science is nice, but let's look at technology. Inflation, everything, so there's a big problem. So the technological turn is a purely economic view about, okay, we have to develop the economy. The future of economy is technology. They don't talk about science anymore. Economic growth will stem from technological development. And what they will create, of course, tech transfers. Okay, we need technology. There's research in the university. Let's create a lot of organizations that will transfer the knowledge from university to industry. So we create a lot of organizations. Centre de recherche informatique de Montréal, CFRIO, which is a centre de it cannot be named, stupid name, too long, but it's on the informatization of organization. Mid-80s computer, so you have to computerize all your organizations, so they create an organization that will help digitize the organization. Biomass, a kind of ancestry of biotech, in fact, but that's the beginning of biotechnology. At the federal level, they create, again in the same year, the Innov Action Policy. So Innov, again, innovation. In Quebec, 1988, another document, to master our technological future by the Liberal Party. So we see that technology is above party. It's a fad. Everyone is doing technology. So they put tax credit for company for doing research, pay engineers. So they have to push the industry to do more R&D. And they put funds for technological development, a lot of hundreds of millions of dollars to finance, again, industrial research. Third part, what I call the third part is innovation policy. So we first, science policy from 65 to 80, 80 to 90 technology policies, and now we're in the era of innovation. We have to innovate. That's the word you hear everywhere. Let's be innovative. I am innovative, of course. We're all innovative. So here's the timeline of all those things, I think. So we have the policy on science and innovation. Parti québécois. Liberal comes, they name a chief, the government here. Of course, that's Canada. They name, under the Liberal in 2004, they named the first chief scientist through Arthur Carty. 2007, the Liberal come, they replace the policy with a strategy on research and innovation. Okay. And that's interesting because I think it means something. We will come to it after. The conservative come back to power, so cut again some science, so they eliminate the chief science advisor, 2001. The Liberal come with again, because it's a 3-year thing. Okay? So after 3 years of the Quebec strategy on research innovation, they have a new strategy of science innovation. They create the Ministry of Economic Development, Innovation and Exportation, which is very interesting, because in the end you have science with technology. Since now you move to innovation, innovation is industry, so it goes not with research, it goes with the Department of Economics. So Department of Economics, no surprise, and exportation. So that's the liberal view. Innovation is linked to industry, science is for the university, so it's higher education. Parti québécois, then the liberal government named a chief scientist, which is still there, Rémy Quirillon. The Parti québécois come back to power for a couple of months, and they create a national policy on research and innovation. Then the Liberals come back to power and they scrap this national policy and they say, let's go back to a strategy. So what's going on in there? I think what's going on in there is that when you have a nationalist government, he wants to show that he's doing a national policy. And policy is a broad view of things. It's a political discourse. We have a national policy. The Liberals want to be strategic. They don't want policy, things like that. They want, hey, we are, moving things. So they call it a strategy because it looks more hands-on. So it's not just a change of word. It's a change of perception about what we want to present ourselves as doing strategic move, strategic investment. So the word strategic is everywhere. It's a strategic presentation here, of course. If you really read what I put, you would say, there was some strategy behind this. And then Liberal comes back at the federal level. They bring back the chief science advisor in Mona Nemer. So those were the big science policy 60s, 80s, technology, 2000 innovation. What are the consequences of this transformation? In fact, it changed the types of investment. Since the end of the 90s, government create strategic organization. Instead of doing as it was doing, giving the money to the three council in a kind of republic of science, you have the republic of science, we are the council, give me the money, we'll do research. That was the idea behind the endless frontier, the idea that NSF is at arm's length from the government. Since the government now is more interested in technology and innovation, you want to have a better control on those investments. So he says how to do that. At the end of the 90s, he said, we know how. Instead of giving the money to the three councils that are autonomous, we'll create parallel organization. CFI, Canadian Foundation for Innovation, Genome Canada, and of course Quebec follows up, Genome Quebec. Means that government, instead of giving the money to NSERC and CIHR saying, here's money, do genomics, because in fact genomics is linked to CIHR and NSERC, they said, okay, now we create something else to be sure they're doing genomics. And in fact, it's a fact because I was struck by the last federal budget in which, in fact, they give money to a lot of places, but they don't really mention Genome Canada. And I think that explains that the head of Genome Canada a couple of years ago resigned. He said, okay, there's no money anymore in that. The fad of genomic is finished. Now the fad is artificial intelligence, of course. Everyone is talking every day about artificial intelligence. And the government said, okay, let's put money there. And the last government put at least $100 million on artificial intelligence. The latest fad. And as I said, they targeted outside the three council. And also there's a change in the kind of research that is perceived as important. We talk everywhere about interdisciplinarity, and with Rémi, the chief Quebec scientist, he launched a new word, which is no more only interdisciplinarity, but intersectoriality. Intersectoriality is a new word to say, oh, it's not only that we have to be interdisciplinary, like an engineer, with a physicist, with a physician. We have to be intersectorial. We have a sociologist with a physicist, with a physician. Between the three councils, they have to collaborate more and more. They call that intersectoriality. And now object-oriented, of course, it was in the 80s, biofuels, proteomics, nanomaterials. Now, of course, it's artificial intelligence. And it has to be interdisciplinary. Why? We don't know. We have only said that it's better to be interdisciplinary. So maybe I have no clue. We have to check if it works. Intersectoriality is supposed to be in itself good. Maybe we can say, no, it's the reverse. It should be that. Tell me the problem you want to solve. Then I will look at it and say, oh yes, here you need sociologists because it's health problems and you need a physician. So you are intersectorial. But if you want to solve the problem of nuclear reactor, 2 engineers will be enough. There's no intersectoriality there. So intersectoriality should be linked to the problem to be solved and not the mantra that the world will be better if we are all nice and good to everyone. That's about the discourse we hear now. which is irrational, exactly. And it has institutional consequences, of course, is that the research teams are the center of things. We want people to in teams. If you ask a grant and you say, I want to do something alone, you say, well, who are you? You won't get the money with that. Have a couple of friends around and you'll be a team. And in better, like Sears, a research center. And then you get the money, as we do, of course. And which means in terms of institutions that if we go back to the beginning of the 20th century, departments were the place where research was going on. Physics department. No, physics department is a place where the researcher meets once a month to ask a few things about teaching, and they go back in their labs because it's not the center of definition of research. Departments are the place for teaching now, and research are research center of proteomics, center of everything. Which means that it reverses the usual way of doing things. Up to the mid-80s, research was perceived as disciplinary. You have a discipline and you have objects. You have astrophysics, physics, nuclear physics, optics, all kind of physics, of object of physics. With interdisciplinarity, in fact, it's a reverse. I call it object-oriented. You say, okay, I want to solve cancer. Or I want to, like at Sears, I want to understand this phenomenon called science. What is science as a social phenomenon? Then you say, my object is science. Okay, I need a philosopher of science. I need a sociologist of science. I need an economist of science. We have all of this at Sears because our object is science. You want to solve cancer, you need now physicists because you need lasers to excite the cells and see how it reacts. You need, of course, nuclear physicists because of the nuclear aspect of it because of cancer. You need physicians, you need cytologists, you need geneticians, and now you need, of course, computer scientists because you have all the database of genomics. So it's exactly the reverse. It's research oriented, it's object oriented, discipline around the object instead of the discipline saying, okay, let's do atomic physics, or let's do the sociology of family, let's do the sociology of immigration, let's do the sociology of women, let's do this. It's exactly the reverse. And talking about intersectorial collaboration, I have some data, they are old, but it's all the same. The university is at the center of the system. Government labs, when they publish, in fact, half of their paper with university people. Industry, when they do papers, they do it with university. Hospital, of course, that makes sense. Even federal government labs work with university. So there is a tendency to forget that, in fact, the university has never been a so-called tower, ivory tower. It's totally interconnected with all active. People don't know it. Example, the new president of NRC said a couple of months ago, okay, in our new strategic development, we have to have more relations with universities, but you have already 3/4 of your papers are written with universities. You should know it first before saying we have to collaborate more, because you don't know you are already collaborating. So there's a lot of discourse, which is instead of being based on data, they say that, oh, it's good to collaborate. But we already collaborated. So the problem is not there. It's somewhere else. And of course, this mantra of industrial development has been raised in collaboration between university and industry, which is also linked to the government de-investment in university, because government put less money in university has to find the money somewhere else. It cannot take it too much in Quebec, at least in the pockets of students, so he has to go in the industry. He has not 25 places to go. Or philanthropy, try to find a nice guy who has $1 billion to burn on some gadget, science and religion with the Templeton Foundation, or finding extraterrestrials like the Russians new rich. Story stupid, but that's the way it works. Budgets, and here you see the budget, and you see it's stable since about the election of the conservative government. 2005 is the cutting about. Now it's maybe starting again. Of course, 2017 there's a boost with the Trudeau government, but not big. In Quebec, same thing. You have the health. It's surprising here that the health research is about equal to NSERC. In the States, the health research is about 3 times, 4 times the National Science Foundation. I'm very surprised that there's less of that. Here, it's this health sector has more money, makes sense. Government represents people are afraid of their health. They said, put money in health research. That's good. The rest, that's okay, but we don't care. What does that mean now? Okay, let's look at what is the reality behind the whole discourse about, yes, we are in a knowledge economy, science is important. Let's look at the data. The data means essentially one thing. Since 2005, general decline of Canada, general decline of Quebec compared to OECD. So here you have Quebec and OECD for general overall R&D. Quebec is not too bad because it's in fact now, after a big surge over the average of OECD, now it's coming back to OECD. Canada has been systematically below the OECD average. So Quebec was doing better, is still doing better. And maybe it's linked to the fact that there is a strong organization defending science through ACFAS. I think it plays a role. Then we have industrial R&D, which is again, look, is going down the drain compared to OECD, which is going up. Here you have the only place where we're good, and it's a document that university presidents and all those who says that we are underinvesting in university. They don't like me when I show this, so I show it because those are data. We see that, the only place where we are above, way above the OECD is university research. So when they say that there's underinvestment in university, government shows that. And it happens that, yes, that's the case. Now, another down the drain is government research. And government research is fundamental. We have seen that with the creation of the experimental farms, it was what is the object of government? Making sure that there is a national security, health, environment. To do that, it needs internal expertise, because otherwise it will have to ask the company, is your gadget good? Of course. Here's the report done by our researcher, which shows that we are the best in the world and the good and no danger or anything. Oh, thank you very much. That's about they're doing in Canada. They ask the company to tell you that the pill is good. Totally irrational. And why? Because they don't have the internal resource to do it. Same with computer science. Computer scientist says, okay, we'll do a big thing for you. Believe us. They believe them. They create the Phoenix system to make a check. It doesn't work. It costs $2 billion. And now those same computer scientists are telling you that they're doing artificial intelligence. They will solve all problems. So, okay, begin by doing a paycheck. And then we'll talk about the future of intelligence and robots. We have to back to common sense. So there is a total decline of governmental research, and that's very dangerous. That's explained the death in Ontario of the Bickerton or whatever that it was 2000, why they stopped doing tests of the quality of water, and some people died. Those were done by government labs, and they have to be done by them. They are the only one who are the common good. Okay, what does that mean now? Quebec, what is the place of Quebec in the Canadian research system? Here is the percentage of the research funds obtained by Quebec in the three councils. It gives us a weight. So it's about a quarter, a bit more, so it's 27, and Quebec weights about 21, 22. So it's over its average, so it's doing good. But of course, that curve, people don't like that in Quebec. The university president don't like me, because I say, look, we're supposed to be going down the drain since about 10 years. Every year, president of the university says, hey, we are not competitive. I said, it's not visible there. We are very competitive. It's straight line. It's not a rounder. It's not like that. That's going down. That's not going down. Problem. Okay, let's look at some other. Okay, what is the weight of Quebec in the world now? It's easy, 1%. And I recall that to our big guys. Hey, we want to compete with the world. I said, wait, we produce 1% of knowledge. Anyone with a QI of 4, an IQ of 4 will say, okay, that means that I have to absorb 99%. I say, yes. So we have to train people to absorb 99, not to think that with our small 1% we'll create the next thing. But it's hard to convince them of that. So Canada is about 4%, 4.5. You see it went down. And downstairs we have the distribution in social science, but that's not very important. But again, it's about 25% of the papers going on there. What's that? Okay, that's an interesting thing. It's the evolution of international collaboration, because what is the trend since 30 years, in fact? Before the discourse of international, much before, science has always been international. Scientists has always been moving around. Let's measure that with co-publications. We see that, yes, since 1990, from 15%, now we have more than 50% of our papers in international collaboration, which means that not only is that Quebec, yes, not only do Quebec produce 1%, but half of this is done with international collaboration. So that's what we have to do. Collaborate with everyone instead of thinking we're in competition with everyone, which is not true. But it looks better to compete. According to our president of university, our ministers, they talk competition. The reality is that we are collaborating and we should be collaborating. Now, we can say, yes, we have a lot of papers, but what is the quality of this? Can we have an idea of, do anyone reads those damn papers? We have a measure of that through citations. Citations are very criticized, but we have to distinguish levels. There are individuals, we should not look at that, and we have systems. At the systemic level, it's a very strong index. So here for Quebec and for the Canadian average, we see that Quebec is about following the Canadian average, except we see, we'll see if it continues, but since about 2000, there is a tendency of Quebec to be above the Canadian average. Is it? Because, it's 1 point, okay. Here, the Canadian average means that in the world, if you have an average paper, it should be cited as all the paper in the world. You're as good as anyone. Then it's 1. If you are above the world average, you are at 1.1. It means that you are 10% more cited than the world average. And we are more at 120, even 140. So those are good papers in good journal, which are well cited, above the average. What to conclude from this survey about the actual situation? I think I conclude this, that the national priorities, in fact, are based and have been based on successive fads. Biotech, nanotech, now artificial intelligence, autonomous cars. I saw electric cars a couple of days ago in the journals. And it's a purely bandwagon effect. Okay, they're doing it, we should follow. Instead of saying, yes, they're going there, but where are they going? We don't know yet, so let's wait to be sure we want to go there. And second, do we have the money to go there? Can we go there with what we have? Maybe yes, maybe not. But when we look at policies, they never do that. They say, oh, they're doing that. Oh, there's a big brain project in Europe. We should do that. The US followed suit on the Europe. Now it's artificial intelligence. Canadian government, okay, let's put 100 million on artificial intelligence. Why? To do what? To compete with whom? And there is a general decline of R&D over 15 years. And there's a total lack of understanding of the importance of government R&D labs, which is very problematic. And finally, there is a total general weakness since 40 years of the industrial base that bets only on the weak dollar to export. Export what? Natural resources in what is supposed to be a knowledge society. Because that's what we see. Kinder Morgan is petroleum. In the West, it's wood. In Quebec, it's also wood that we send to the US, and they put a tax on you because we are selling them natural resources. But we're supposed to be in the knowledge economy. So there's a lot of disconnect between our data on science policy and the latest fads about artificial intelligence. Thank you. I'm done.